Section 5.2 Interactive Assignment Objective 1. The following table shows the distribution of murders by type of weapon for murder cases in a particular country over the past 12 years. We're going to complete parts A through E. So the first question is the given table a probability model? Why or why not? So here's the table that we're looking at here. And again, we're answering the first question. Now keep in mind that we have to check the first rule, and that means that the probabilities of all events, that is, murder by any of the different weapons in the table, are greater than or equal to 0 and less than or equal to 1. So if we take a look at each of these probabilities, all of these probabilities are in between 0 and 1, therefore it checks for the first rule. Now the second rule tells us to sum together the probabilities of all outcomes. That is, sum together the probabilities for all of the different types of murder weapon. So when we add these together, we take 4.472 plus 0.021 plus 0.033 plus 0.015 plus 0.0132 plus 0.056 and plus 0.141, it equals 1. So therefore, it checks for both rules. So there, we're going to answer our question for part A. And so for part A, we would then say that, yes, the rules required for a probability model are both met. Okay, let's take a look at the next question. Next question says, what is the probability that a randomly selected murder resulted from a rifle or shotgun? So, looking at this next question, okay, what we want to do is we're going to use the addition rule for disjoint events to find the probability. And the rule states that if E and F are disjoint, meaning mutually exclusive, then then P of E or F is equal to probability of E plus the probability of event F. So in our example, we're looking for the probability of the rifle or shotgun because that's what the question is asking. So let's take a look at that here. So the probability of a rifle or shotgun. So that's the probability that we're looking for. So we need to find the probability of the rifle plus the probability of the shotgun. So if we take a look at our probabilities here, okay, the probability of a rifle is 0.021. The probability of a shotgun is 0.033. And now we're going to add them together to get 0.054. So our answer is going to be 0.054. Now the next question is to interpret this probability. Now remember, to interpret this probability, what do we know? We know that when we look at this result, this is 0.054. Okay, now if I want to rewrite this as a fraction, this is going to be 54 over what number? Well, the 4 ends in the thousands place. So this is 54 over 1,000. So that means that this is 54 out of 1,000. So now let's take a look at our choices. Well, it says here that if 1,000 murders were randomly selected, exactly 54. Well, it's not exactly because it can never be exactly. It's either about. So we would say that if 1,000 murders were randomly selected, we would expect about 54 of them to have resulted from a rifle or shotgun. Okay, next question says, what is the probability that a randomly selected murder resulted from a handgun, rifle, or shotgun? Okay, so let's go ahead and take a look at that question. Okay, now I put the table down here again just so that we can view it again. So again, we're looking for what is the probability that a randomly selected murder resulted from a handgun, rifle, or shotgun. Okay, so let's take a look here. All right, now again, we're going to be using the addition rule for disjoint events to find the probability. The rule states that if event E and event F are disjoint or mutually exclusive events, then the probability of event E or F is equal to the probability of event E plus the probability of event F. Okay, so what we're going to do is we're looking at the probability of a handgun, rifle, or shotgun. And so that's what is in our question. We're looking for the probability of a rifle or shotgun, which means that we want to find it's going to equal the probability of the rifle plus the probability of the shotgun plus the probability of the handgun. Now we've already found these two results, but we can write them as separate, or you can, if you've already done that, then you can add those together. Regardless, here we have 0.021, which is the probability of the rifle, plus 0.033, which is the probability of the shotgun, plus the probability of the handgun, which is 0.472, which gives us the result of 0.526. So, putting in our result here, we're going to get the result of 0.526. And now they want us to interpret this probability. Now again, just like we did earlier, okay, we're going to take a look at this decimal. And this decimal is 0.526. Now if we write this as a fraction, this is going to be 526 over, again, the 6 ends in the thousands place. So this is 526 out of 1,000. So now what we can say here is the following. We're going to say that if 1,000 murders were randomly selected, we would expect, we're not going to use exactly, about 526 of them to have resulted from a handgun, rifle, or shotgun. Okay, now the next question says, what is the probability that a randomly selected murder resulted from a weapon other than a gun? So let's take a look at that. Okay, so again, we're going to use the addition rule for disjoint events to find the probability. The rule states that if events E and F are disjoint or mutually exclusive events, then again, the probability of event E or F is equal to the probability of event E plus the probability of event F. Now let's make note that this rule can be extended to more than two events. Thus, to find the probability that a randomly selected murder resulted from a weapon other than a gun, we're going to sum together P of knives, P of hands, fists, etc., and P of other. So we're going to take probability of a weapon other than a gun. So again, a weapon other than a gun is the probability that we're looking for. Okay, now what are the weapons other than a gun? Well, again, we have the probability of knives and the probability of hands, fists, etc., plus the probability of other. Okay, so again, what we're going to do is we're going to take those probabilities from our table. Probability of knives is 0.132. The probability of hands, fists, etc. are 0.056. And the probability of other is 0.14. So when we add those together, we get 0.329. So down here, we're going to take a look at that result. We get 0.329. Okay, now we're going to interpret this probability. So again, similarly what we did earlier, okay, we're going to take a look at this decimal and we're going to convert this into a fraction. So 0.329 can be written as a fraction with 329 over 1,000. So that means that's 329 out of 1,000. And so then we're going to say that if 1,000 murders were randomly selected, we would expect about 329 of them to have resulted from a weapon other than a gun. Now the next question says, are the murders with a shotgun unusual? Okay, well the shotgun represents 0.033. Now remember, if we want to find out if a probability is unusual, in this case a shotgun, typically an event with a probability less than 0.05 is considered unusual. We're going to use the table in the problem statement to find the probability that a randomly selected murder resulted from a shotgun. So what did we get for the shotgun? Well, we can see that, and we're going to compare it to 0.05. So we know that 0.033 is less than 0.05, therefore the murders with a shotgun are unusual. So then we would say that our answer is yes.